Welcome back guys for another video in my Blind 75 challenge. If you're new to the channel, we are solving 75 LeetCode questions that come from the Blind 75 list. These are the questions that at one point in time were the most common questions asked in software engineering interviews. And we are continuing on with our section about linked lists. But before we start, I am once again asking you to click like and hit that subscribe button to stay up to date with all of my latest videos. If you feel so inclined, don't forget to leave a comment down below. Tell me how you're enjoying this section about linked lists. Is there something else that you'd rather see? Do you want me to dive into graphs next? Do you want me to dive into trees next? Let me know in a comment down below. And with that, let's move on to our question. This is number 23. It's the first hard question that we've come across in the linked list section. It is called Merge K Sorted Lists. And the question asks us this. You were given an array of K linked lists, and it's known as the variable name lists. Each linked list is sorted in ascending order. Merge all of the linked lists into one sorted linked list and return it. Example 1 gives us one list of lists, and the individual lists are 145, 134, and 26. The output, of course, gives us them lists all merged together in ascending order. Example 2 gives us an empty list, and we return an empty list. And then example 3 gives us one empty list inside that list wrapper. And then in this scenario, we just want to return an empty list. So there's two main ways to solve this one. In the first solution, we make use of a queue, and we're just going to iterate through every single element that it gives us in this list of lists, and we'll add them to an implementation known as a priority queue. A priority queue is used when all of the objects are supposed to be processed based on a certain priority. So for our integers, they would automatically be sorted in an ascending order. This way we can just continue to remove the integers from the queue and then just create a second linked list and then return that linked list. Let's take a look at what that looks like. So before we get too deep into the solution, we of course want to think about what happens if lists that's passed in is null, or lists has a length of 0. Well, we want to take care of that and return null also. So we'll do if lists is equal to null, or lists.length is equal to 0. We just want to return null. Okay, next up, let's instantiate our priority queue. And that's going to be of type integer. And we'll just call it queue. And then let's loop through this list of lists. So we'll do for list node, node in lists. And we'll say while node does not equal to null. And we just want to add it to the queue. So we'll do queue.add node.value. So we're not actually adding the nodes here, we're just adding the values that we've found. And then node will equal to node.next. And it'll just continue cycling through. Inside the while loop, we're cycling through the individual lists. And then inside the for loop, we're cycling through the list of lists. Okay, so we've collected all of the values in that priority queue. They'll all be sorted in priority order. Next, we just want to set up another list node. We'll call that current, and we'll just set it equal to that first node. But what we also want to do is check to see if the queue is empty. If the queue is empty, that means there was no values in our list of lists. So we'll just want to set it as null. So we're going to use the ternary operator here. We'll just check if the queue is empty. And if it is, we just want to return null. And if it's not, we want to return a new list node. And we'll want to set it to the first node inside that queue. And then if you check the constructor here, we can also define a next value. For now, we'll just set that equal to null, because if it was the last one in the list, we of course want that next pointer in the list node equal to null. So let's copy that into a result head. And we'll just set that equal to current. And we're going to set up our while loop. So we'll loop while the queue is not empty. And inside the while loop, we're just going to pull from that queue. So we'll do list node next equals new list node. And we'll do the same thing. We'll remove from the queue. and we'll set the next node equal to null. And we want to attach that to current, so we'll say current.next equals to next, and then we'll just move current up to next. So we'll just continue on, we'll loop through this while loop, and it'll pull all of the integers from the queue and set up the linked list exactly how we want it, and we can just finally return result head. Let's go ahead and submit that and see what it gives us. Great, so it's accepted our answer, but as you can see, it's only faster than 24.75% of Java submissions, so this indicates it's really kind of slow. Arguably, we might want to go for readability here. It's super simple to understand if someone's coming into this blind and looking at it and saying, what does this do? But the space complexity of the algorithm runs in big O of n, or linear, because we have to create this new queue for every single element in the array of list nodes. So let's see if we can come up with something a bit better. Well, these kind of problems where we're wanting to splice together a list of lists really lends itself well to the divide and conquer technique. The divide and conquer technique is simply an algorithmic strategy to solve these kind of problems. The basic concept of it is that we're going to divide, conquer, and then combine. When we divide, that means we're going to break down the given problem into sub-problems of the same type. The conquer portion is that we're going to recursively solve a sub-problem, and then the combine step is that we're going to appropriately combine the answer. One example of this is MergeSort, so if you have any idea how MergeSort works, let's go ahead and pull that up. Just to show a good example. So MergeSort, here we go. So as you can see in MergeSort, we're just taking an unsorted list of integers and we're sorting it in ascending order. So first of all, the algorithm breaks it down into individual integers, and from there we just take each pair and put them in the correct order. So now we have pairs of integers. Then we combine those subsets into a list of 4 integers and 3 integers, and then finally we're just going to slot everything in the correct place, which means it's in ascending order. And it's the same kind of strategy for how we're going to solve this problem. So let's go ahead and get rid of the code that we had for the priority queue solution, and we'll go through a divide and conquer solution. Now with this solution, the basic idea is that we don't really need to traverse most nodes many times repeatedly. We can just divide the lists in half until there's only one list, and then merge them together one by one to get the final result. Let's first start with setting up that base case of the null values. So we'll say if lists equals null, or lists.length equals 0, we'll just return null. And then next up, let's create a new method that we're going to call to divide our lists down into single elements. So we'll say private list node, and we'll call it divide and conquer. It'll take in an array of list nodes. We'll just call that lists as well. And we also want to input the bounds of this list. So we'll say int low and int high. So for this one, we're just going to recursively call it until we've got individual nodes. So how do we know when we've got individual nodes? Well, in that case, low will actually be higher than high, and this is how we'll know that we've hit our base case and we want to break out. So we'll say if low is larger than high, and in that case, we just want to return null. And next up, we'll just want to check if low is equal to high, and if this is the case, that means we've broken it down into one individual element. So we'll return lists of low. And then if none of these cases match, it means that we've not broken everything down. So we're just going to do a simple recursive call to divide and conquer, sending in the lower part of the list and the higher part of the list. So it looks pretty similar to MergeSort. We're just going to do int mid, and we'll do low plus high minus low, and then we'll just divide that by 2. And then we'll set list node left equals to divide and conquer. And we'll pass in lists, we'll pass in low, and we'll pass in that midpoint. So we're sending the lower part of the list. Then we'll instantiate another list node called write equals divide and conquer. And we'll pass in lists. We'll pass in mid +1 because we don't want to pass in the value at mid because we've already hit that. And we'll pass in high to give divide and conquer that higher bound of the list. And then our final step is merging the lists. So we just want to return the value that we'll get by calling a method called mergeList, and we'll give it left and right. And let's define that method. So we'll set it to private. We'll return the list node, call it mergeList, and we'll want to pass in a list node called list1 and another list node called list2. And we're just going to merge these together. We'll just set up a list node, set it to dummy equals to new list node, and we'll set the value to that equal to -1. Then we'll set up another variable called previous, and we'll set that equal to dummy. We'll say while list1 is not equal to null and list2 is not equal to null. Inside this while loop, we'll want to check if list1.val is less than list2.val. We just want to set previous.next equal to list1, and then we'll move list1 up one place to list1.next. Then if the value at list1 is not smaller than the value at list2, we'll just set previous.next equal to list2, and then list2 equal to list2.next. And then finally, we'll set previous equal to previous.next. And then when we've broken out of that while loop, we'll just want to set previous.next either equal to list1 or list2. To check that, we'll just check if list1 is null. So we'll say previous.next equals to list1 not equal to null. If it's not equal to null, we'll just set it to list1. If it is equal to null, we'll set it to list2. And then finally, we just want to return dummy.next to point to the start of our list. And that just about does it. The last thing we want to do is just call divide and conquer at the top here. So we'll say return divide and conquer, and we'll pass in the lists. We'll pass in 0 for the low bound, and we'll pass in lists.length -1 for the high bound. And let's go ahead and submit our answer and see how much faster that is. Great, so it's much faster. It's faster than 96.83% of Java submissions. So I'd say this is overall a better solution. If you ever see a question like this, just try and think about some kind of divide and conquer technique to solve it. And with that, that wraps up another question on our Blind 75 list of LeetCode questions. Again, we're going through the questions all concerning linked lists. If you're enjoying the video, don't forget to click like and hit that subscribe button, and I'll see you tomorrow for another question.